A RealWave surface is a deformable mesh that can be used to create various types of water surfaces, from large oceans to small ponds or puddles. It is even possible to import your own geometry via SD files from external 3D applications. To create a new RealWave mesh, simply add a new surface from the RealWave menu. You can now see a squared surface with a hexagonal pattern in the viewport. In the Nodes window, you can find a new object and, if you expand it, you will see a so-called modifier. These modifiers are used to add, create, and mix the different wave types. Adding a new wave modifier is very easy. Simply right-click on the wave node and choose the desired type from the Add Wave menu. Once you have made your choice, the modifier will be linked to the mesh. With most modifiers, you will not see any change, and if you want to apply the wave structure, just reset the scene. If you want to change the shading mode, just use the number keys from 7 to 0 on your keyboard. It is possible to add as many modifiers as you want, and you can combine them without limits. It is also important to know that the RealWave surface and the modifiers have completely different parameter sets. The mesh-based settings are used to activate foam and displacement maps and define the polygon size. Lower polygon size values will increase the number of details on the surface, but also increase simulation time and file sizes. One of the most versatile modifiers is the statistical spectrum surface, the one that has already been linked. The statistical modifier shows the typical look and feel of an open ocean and supports cresting waves. Other modifiers can be added exactly the same way, and the result is a mixture of all these different wave types. Very interesting effects can be achieved with a combination of the fractal and the Gerstner modifier. While the fractal type creates a bumpy surface with a rather high base amplitude, the Gerstner wave adds crests. A wave surface like that is perfectly suited for very large ocean simulations. As an example, let's create a surface with a combination of the fractal and Gerstner. Later, we will also write out foam maps with the help of the crest splash emitter. We start again with a plain RealWave surface and add a fractal modifier. When you hit Reset to apply the modifier, you will see that there are hardly any visible details. To change this, Fractal provides two main parameters. The first one is Octaves. This setting ranges between 1 and 8, though higher values are possible, but they will hardly show any effect. This parameter adds noise to the surface and, with lower polygon size settings, you will see more fine details. Another important setting is slope. It is the vertical height of the fractal structures and can also be seen as the mesh's bumpiness. Good values normally range between 3 and 5. In the next step, the Gerstner modifier is added. Choose it from the context menu and go to Node Params for the settings. You can see that the parameter set is completely different, but there are also similarities, for example speed. The amp wave parameter defines the wave's vertical height, but also the sharpness of the crests. Light wave is responsible for the number of wave crests and also knows the frequency. If the waves are too fast, it is possible to use speed settings smaller than 1.0. From this setup, we will now create foam maps with the help of a crest splash emitter. This type is a normal particle emitter, but only works in combination with a RealWave surface. It produces dumb particles by default, and is therefore very fast. To get foam maps, it is necessary to activate this feature in the mesh's node params window. When you change Calculate Texture to Yes, you will have access to the associated settings. Resolution is just the size of the final map given in pixels. Diffusion determines the propagation of the foam patterns on the surface. The propagation should match the wave's own speed, so it is important that this is not too fast. The dissipation value is responsible for the foam pattern's lifespan. In this case, the foam marks should vanish after a rather short period, and therefore a value around 1.5 will be used. Finally, it is necessary to activate the export of the foam maps in the Export Central dialog. To open it, press F12, then expand the RealWave tree and check Foam Map. The files will be stored in the project's image folder. In the next step, the crest splash emitter will be added. You can either select from the RealWave menu or the Viewport's right-click menu. It is not necessary to link the emitter to the RealWave node because this is done automatically. The emitter also requires two different settings. The first one describes the interaction between the water surface and the particles. The second one triggers the creation of foam. In this example, the particles should not deform the mesh, and therefore hit force is set to 0. The on-surface option remains untouched because we want the crest particles to become deleted when they touch the surface. With texture strength, it is impossible to control the combination of the particles to the foam map. If the foam marks are not strong enough, please try to increase this value. To trigger the creation of particles, you have to tell RealFlow the conditions. As you can see in the node parameters panel, the choppiness for emission value is 0.2, but this parameter is actually only relevant in combination with the statistical spectrum modifier. Here it has no meaning and must be set to 0. The height for emission parameter has far more influence and is related to the wave's vertical height. If you only want particles at the wave crests, increase the value, for example to 0.25. This value, by the way, is given in RealFlow units. When you start the simulation, you should already see the foam marks on the surface. If they are not visible, please change the shading mode to smooth with the 0 key. You can also see that the particles are displaced from the surface, leaving the mesh, and have a rather long lifespan. To get rid of these unwanted effects, daemons are needed. The most important daemon is certainly gravity, because it will force the crest particles to fall down. All daemons will be added from the appropriate menu. To reduce the lifespan of the particles, a k-age daemon is used. The daemon's life value is given in frames, as well as the variation value. Since we want to remove the particles after a very short time, life will be around 10 frames, and variation is set to 5. These values create the impression of rapidly changing white caps on the top of cresting waves. The simulation now looks very good, and you can see that it is no longer necessary to remove any particles outside of the surface because of their short lifespan. If you do not want to use the crest particles for rendering, you can disable their export features with the icon bar's inactive button. This will drastically increase simulation speed. RealWave surfaces are a very good method to create convincing ocean simulations with just a few minutes. The supporting emitters also help to get secondary effects like foam, whitecaps, or splashes.